So in this video, we're going to talk about verifying trig identities. So far, we've worked on simplifying them. So in this part of the unit, we're going to try and prove that one side of the equation equals the other side. So we ultimately know what our answer is going to be. We just have to find a path that gets us to that answer. So when we're trying to verify or prove statements are true, you should only work on one side of the equation. Don't start moving things left and right with adding and subtracting. If you run into a dead end, you might want to work the other side to see if you can get it to match the side that you have already worked through. Again, you cannot move things across the equal sign with addition and subtraction because it changes values in our equation. So here's our first example. We want to prove that tangent squared plus secant squared equals 2 tan squared x plus 1. Okay, so I'm seeing tangent squared already over there in that left side. And on the right side, I'm seeing a 2 tangent squared. So I personally am looking at the fact that I already have tan squared. So maybe there's a possible way that I can get another tangent squared. So for me, I would be looking to change that left side of the equation. And I'm going to change my secant squared. Right? I know that secant squared with my Pythagorean identity is tan squared plus 1. So I'm going to have tan squared x plus tan squared x plus 1 equals 2 tan squared x plus 1. And now I have got 2 tangent squareds on my left side, so I can simplify that to 2 tan squared x plus 1 equals 2 tan squared x plus 1. And now I have verified my identity. Both the left and the right side look exactly the same, so therefore we have solved our equation. All right, so I'm looking at my left side and my right side. I have tan squared, or tan to the fourth x plus 2 tan x squared plus 1 equals secant to the fourth x. Now the right side to me looks a lot prettier than the left side, so I'm going to try to work with the left side to see if I can get it down to the right side. And I'm seeing that I can factor the left side because I have to the fourth power. And a second power there. So I'm going to rewrite this other side factored. So that's going to be tan squared x plus 1 times tan squared x plus 1 equals secant to the fourth x. And now I have 2 of my Pythagorean identities there, or my factors. So I'm going to have tan squared x plus 1 becomes secant squared x using my Pythagorean identities. So I have a secant squared x and another secant squared x equals secant to the fourth x. And secant squared times secant squared is indeed secant to the fourth x. When we're doing these, we really need to make sure that we are writing out all of our work so that I can follow all of the steps that you are taking. There are multiple ways to solve these problems, and there are multiple correct answers. As long as I can follow your work and your work is correct, you will get full credit on these types of questions. All right. This one's going to take a little more work and a little more space, so make sure you give that to yourself. Okay, I have cosine theta over 1 minus sine theta minus cosine theta over 1 plus sine theta equals 2 tan theta. Again, I'm looking at that right side. I'm saying that is the simpler side, so I'm going to try to work with the left side to see if I can manipulate it to give me 2 tan theta there on the right. When I'm adding and subtracting fractions, the bases have to be the same. So I have to multiply the left side by 1 plus sine theta on the top and the bottom. And the right side by 1 minus sine theta. All right, so in the top there on the left, I'm going to have cosine theta plus sine theta cosine theta all over 1 minus sine theta 1 plus sine theta. Then I've got minus cosine. I'm going to put this in parentheses so I don't forget to distribute that negative that's out there. So cosine theta minus sine theta cosine theta all over 1 minus sine theta 1 plus cosine or sine theta, sorry. And it still equals that 2 tan theta over there on the right side. All right, so I have to remember to distribute this negative in, which is why I made sure to put um, that in parentheses. So it's going to be a minus cosine theta and a plus sine cosine theta. So in the top, now that my bases are the same, I can simplify what's in the top. So I've got a cosine minus a cosine, those cancel. And I've got a sine cosine theta plus a sine cosine theta, which gives me 2 sine theta cosine theta. And I'm looking at the bottom versus my top, and I'm saying, well, I don't see anything there that can really cancel, so I'm actually going to multiply out my bottom, because I left my bottoms just in case I could factor out something to get 1 plus sine, but there's no addition happening in the top, so I can't factor anything out. So I'm going to multiply out my bottoms, and I'm going to get 1 minus sine squared theta. Okay, and it still equals that 2 tan theta, because that's what we're trying to get to. The bottom, 1 minus sine squared theta, is another Pythagorean identity, so I could change the bottom to cosine squared theta. But my top still stays the same. All right, so I've got a cosine in the top and 2 in the bottom, right, cosine squared. So it's going to cancel out the 1 in the top, and the 1 in the bottom is just going to become cosine. So that's 2 sine theta over cosine theta equals 2 tan theta. We're almost done. Sine over cosine is indeed tangent. So then I've got 2 tan theta equals 2 tan theta. Please make sure you always finish it out. Your last statement should say that the left side equals the right. So that's why I have 2 tan theta equals 2 tan theta. All right. So we have got something on the left here and something on the right. Okay. You have to choose which side you want to start with and where you want to go with it. I'm going to choose the right side over here, the secant theta plus the tan theta, to try to equal cosine theta over 1 minus sine theta. So I'm going to leave what I have over there on the left. Okay, equals secant, which is 1 over cosine theta, plus sine theta over cosine theta. All right, so let's see. We've got cosine theta over 1 minus sine theta equals 1 plus sine theta over cosine theta. All right. Well, looking at that, I'm like, man, those look close, but they're like reciprocals. So what do I have to do? What can I change? What can I do to make these equations equal? All right, so I don't know. I'm like, that right side and the left side look close, but not so much. So I see that the bottom of the left side is 1 minus sine theta. And recall in Algebra 2, you had this process of multiplying by the conjugate. So let's multiply the left side by the conjugate to see if we can get it and manipulate it to be that right side. So notice that I am switching to the other side. And that is okay, but I'm not multiplying things across or adding and subtracting across. So I'm going to do 1 plus sine theta okay, for the top and the bottom there. So I'm going to get cosine theta plus sine theta cosine theta. And then in the bottom, I'm going to get 1 minus sine theta squared. Okay, it still equals that 1 plus sine theta over cosine theta. All right, so the bottom, I'm seeing I can switch to cosine squared theta. Oops. So let me rewrite my top. That is, I'm going to pull out cosine there from the top. So I'm going to get cosine theta, because I had multiplied it out, which I probably shouldn't have done. 1 plus sine theta, okay, over cosine squared theta. So I have a cosine in the top and a cosine in the bottom. So see, I did not realize I should not have multiplied it out, and it's okay, I just write it back out. This is a thing that you can do. And I could cancel the cosine with the cosine squared in the bottom, and I'm still left with the cosine there in the bottom. So again, I have 1 plus sine theta over cosine theta, which equals 1 plus sine theta cosine theta. And now we have verified that they are indeed both the same. Okay, the key there was to multiply by the conjugate. So if you have any questions, please feel free to see me in class or stop by, and I hope you found this video helpful.